Good morning, Comets. Today I wanted to talk about radical equations. These are equations that involve radical signs. So the first step of any radical equation is to isolate the radical on one side. I want to take the square root or the cube root, whatever root I have, go ahead and get it on one side by itself. Because once it's by itself, you can eliminate it by squaring, cubing, or really raising it to any power that is the same thing as the index. If you look right here, the index of this radical is 2, so I have to square it. The index of this radical is 3. It's a cube root, so I have to cube it to get rid of it. Once that's done, I can finally solve for the variable and check my solutions. It is very important to check all your solutions to these equations because you could get solutions that don't actually work. And in a next video, I'll show you a solution that doesn't work. So let's go ahead and try a really quick example on this. Square root of x plus 2 is equal to 3. So what you'll notice about this is that the radical is already isolated on one side, and it's a square root. So what I'm going to do is I'm going to square it. And to make it fair, I have to square both sides. So the radical goes away, and whatever's on the inside is just going to come out. I get x plus 2 on this side. And on the other side, I get 3 squared, which is 9. So now I'm in a position where I can get the variable on one side by itself. And all I have to do is the opposite of adding, which is subtracting. And I get x equals 7. Alright, so going off to the side, let's go ahead and check this. What if I go back to my original equation and I just let x be 7? Let's see what happens. So I have my square root of 7 plus 2. Notice that the 7 has taken the place of the x. And I want to see if I get 3 at the end. Well, what's 7 plus 2? That, of course, is 9. So I get the square root of 9 is 3, which means 3 is equal to 3. So if you get a true statement like this, that means you got one of the correct solutions. Let's go ahead and see another example just like this. Alright, so here I have a square root of x divided by 2, and a minus 1 is equal to 3. The first thing I'm going to do is I'm going to get rid of this minus 1. And the way I can do it is by adding to both sides. So once I do that, I can get this radical and this 2 by itself on the left side. And if I add 1 to the 3, I'll get 4. The next thing to do is to get rid of this 2 at the bottom. And to get rid of a bottom number, I have to multiply by it on both sides. So if I multiply both sides by 2, check out what happens. The 2 on the bottom goes away, but this 4 is going to double to become an 8. Now we have to get rid of the radical. So because it's a square root, I have to square both sides. And once I do that, I get 64. Let's go ahead and check the solution. What if I let x be 64? Let's see what happens. So I'm taking the square root of 64, I'm dividing it by 2, subtracting 1, and I should get 3 when it's all said and done. So we know that the square root of 64 is 8. And we know that 8 divided by 2 is 4. And we know that 4 minus 1 is indeed 3. So I get another true statement. That means that 64 must be a solution. Alright, thanks for watching. Like and subscribe.